Alright, so we are given a problem. The goal of this problem is to find the area inside one leaf of the four-leaved rose, which has the equation r equals 9 cosine 2 theta, which I have plotted out to the left here. In part 1, making use of symmetry, the area of one leaf of the four-leaved rose is represented by the following integral from 0 to pi over 4. And they give us our integral with our bounds 0 to pi over 4, and they tell us for some reason to change it from theta to t, which doesn't really mean anything. You're just changing your variable. Maybe it's in preparation for parametric equations or something like that. Anyways, so what I'm thinking they're already telling us right when I see this problem is I believe that they're giving me our bounds from theta equals 0 to, I don't know why it changed there. Okay, whatever. To theta equals pi over 4. And I'm proposing that they're giving us half a leaf, but we don't have to assume we can test this. And how we can test this is we see that r is at a max value here. R is at a max value here, and a minimum value when it comes all the way back to where r equals 0. So we need to see what two theta values puts r at max and puts r at 0. And if we write out our equation, we see r equals 9 cosine 2 theta. And looking at this in the first quadrant, we see that when theta equals 0, cosine 2 theta, and I'll write this out. When theta equals 0, r equals 9 cosine 0 times 2 is 0, which cosine of 0 is 1, we get 9, because that goes to 1. Alright, so we see that our r max is at theta equals 0, but when's our r min? When does it come back to r equals 0? Well, cosine in this first quadrant here, cosine of theta is 0 when theta equals, or cosine of something is 0 when that something equals pi over 2, because it's a vertical line. So 2 times something has to equal pi over 2, and 2 times pi over 4 happens to equal pi over 2, and that will zero out our entire term. So I'll write this out. So r equals 9 cosine 2 theta. But again, I want to find something that makes r 0 in the first quadrant here, which is, just over here to over here. So I say, well, theta equals pi over 4 does that, and we test it. 9 cosine 2 pi over 4, because 2 times pi over 4 is 2 pi over 4. R equals 9 cosine pi over 2 equals 0. So theta is going from theta equals 0 to theta equals pi over 4. And now we can confirm that that is indeed half a leaf. That is indeed half a leaf. Okay, so now for part 1, the integral. We have our integral, they give us some bounds, and we confirmed our bounds. Let me find something different here. And we're going from 0 to pi over 4. I believe that's what ooh, don't touch the screen. So, yep, 0 to pi over 4. And our equation, our r value, they gave us is 9 cosine 2 theta. But when you're plotting or when you're taking integrals in polar coordinates, there's a certain formula you have to use, and that is 1/2 r squared d theta. 1/2 r squared d theta. And in this case, our r is 9 cosine 2 theta. And the reason we use that formula, and I'll try to do this quick, the reason we use that formula is because think circular and think radii. I don't know if that's the plural or not, radii. So if we're thinking about a circle, we know that in which polar coordinates are operating in a circular fashion. The full area of a circle is pi r squared. Now, if I was taking a portion of the circle and I wanted to find the area of that portion, well, I could use the angle here, which is theta, and take the ratio of theta to the entire angle, which we have theta over 2 pi. Which we have theta over 2 pi, and we'll say this is our portion. Well, then if I multiply our portion by our area, I get pi r squared theta over 2 pi. Our pi's cancel, and we get r squared theta over 2. Now, when we're talking about polar coordinates, specifically, that theta here actually turns to a d theta because we're taking infinitesimal, man, that is a hard word to say, infinitesimal angle measurements of our r as we're encompassing our entire area. So that's why theta turns to d theta there, and that's how we get our little formula there in a very not so great explanation. But so now that we've determined our integral, let's go ahead and plug in our r. And again, I said they gave us our r already, which is 9 cosine 2 theta. Now let me zoom out here. They gave us our r, so we have our integral 0 pi over 4. Let's pull our 1/2 out and make things easier. Now we have our r squared, but our r is 9 cosine 2 theta squared, because our r was squared and r is 9 cosine 2 theta, d theta. Well, I can go ahead and square this 9 and I get 81, and so I go ahead and pull that out. Now I have 81 halves, 0 to pi over 4, cosine squared 2 theta, then d theta. And now I'm going to do a trig identity, and again, once again I pulled it up. What trig identities you see here? Let's look for what I can do with the cosine squared. Nope, I see it right here. Cosine squared equals 1 plus cosine 2 theta over 2. Remember, we already have the 2 theta here, but we can still do it. So let's get crazy here. So our cosine squared 2 theta turns into 1 plus cosine 2 times 2 theta, which is 4 theta over 2. Now I can add my other stuff. I really hope I don't run out of room here. Now I can add my other stuff, and I have my integral 81 over 2, and this is all d theta as the integral goes. Theta goes from 0 2 pi over 4. Alright, so I'm going to go ahead and pull my 1/2 out now, and I get 81/4. And I like to do this, not everyone does, but I do, and I always do this. I'm going to break up my integrals. So I have 81/4, 0 to pi over 4, 1, I pull my 1/2 out, remember, plus the 81/4 is distributed, remember it's times this whole thing, plus 81/4, 0 pi over 4 cosine 4 theta. Alright, and this is a d theta there and a d theta there. Okay, so from here now, I can go ahead and solve this one for sure. Let's switch colors. Red's getting boring. 1 d theta is just going to turn to theta. So I have 81/4 theta evaluated from 0 to pi over 4 plus, I'm going to do a u substitution here. Let's let u equal 4 theta, du equals 4d theta. So I have to, I'm adding a multiple of 4 inside, so I'm going to have to take a 4th outside. So I get 81/16. Right? If you don't see, divided by 4 there. So now my 4d theta that I put in here, I'm going to take a 4th out. Hope that makes sense. 81/16, 0 to pi over 4. Cosine u du. But I never do this, and I don't know why, and you probably want to. Most people will tell you to go ahead and change the limits of your integration in terms of u, but I'd rather just change it back. To me that's easier. So now I have, we'll go ahead and evaluate this. Now I have 81/4. Well, theta is evaluated from pi over 4 to 0, so it's basically pi over 4 minus 0. Pi over 4 plus, we have 81/16. U is just cosine 4 theta. So now I have 81/16. And cosine, the integral of cosine is sine. 81/16 sine 4 theta evaluated, not the 81/16, but this is evaluated from 0 to pi over 4. And we can see that the sine term here, is actually going to go to 0 because sine of 4 times pi over 4. We'll go ahead and write that. Let's just look at sine pi over 4 times 4. 4's cancel and I get sine pi 0. And sine 4 times 0 is 0 equals 0. So I don't even have to worry about any of this. And all I have now here is 81/16. 81/16. And 81/16 81 pi 16ths. And that 81 pi 16ths, that 81 pi 16ths is the area of half of one of the petals, half of one of the leaves. So if we want to get a full leaf, we want to get the whole thing, we need to multiply that by 2. So 81 pi 16ths times 2 equals 81 pi 8ths. And that is the area of one leaf. 81 pi 8ths. And I just noticed this, but I skipped the first part. It's late, I'm sorry. But the first part, well, we're given our r equals 9 cosine theta. And I went over that at the beginning. We had our integral 0 to pi over 4. And remember the integral of polar coordinates, 1/2 r squared d theta. For some reason, they don't let you pull your 1/2 out here. But our r in this case was 9 cosine 2 theta. So, where did I get this weird brush? Maybe this is better. Oh my gosh. Alright, whatever. We're just going to go with it. So, now, 0 to pi over 4, which we already have. 1/2 r is 9 cosine 2 theta squared d theta. And if we want to change this in terms of t and dt, well, we just replace every theta. 0 pi over, oh my gosh, 0 to pi over 4, 1/2, 9 cosine 2t squared dt. And that, I believe, will suffice for an answer to part 1, because you do not need to simplify your answer. Use t in place of theta. Well, what did I do here? I didn't simplify it for sure. I used t in place of theta. And so I'll write this in here. So thus, therefore, our answer is 1/2 9 cosine 2t squared dt. Let me know if there's any problems with these answers, and I'll try to work through it and fix it.